Hello everyone, welcome to the practical session of power electronics and application. So today we are going to simulate a single phase full converter. So you can see this diagram as we have studied in the theory part, the single phase. So at input side you will find the single phase AC supply and it is a full converter. So full converter consists of only thyristors, as semi converter consists of thyristors as well as diodes. So today we are going to study this full converter simulation. So that's why we need all four thyristors, as it is a single phase full converter, and it at the load side there may be resistive load, only resistor, or inductive load, that is a RL branch. So let us simulate this. So what are the components that we need? AC source as an input side, then 4 thyristors and 4 pulse generators we will need, and then the resistive load at load side. So let us start with the simulation in MATLAB. Open MATLAB and then click on new Simulink model. So the window will get pop up. In that there is an option library browser. So you can find whatever the components you need. So I will take 4 thyristors, add to your project, and then at input you need a AC source. So let us take a single phase AC source. At load side you need a RLC series branch. To observe this waveforms, a voltage, load voltage, or you can say output voltage, we need one voltage measurement block. We can also check input voltage or input waveform. So I am taking 2 voltage measurement blocks, then scope to observe the output, and then we need pulse generator. And then power GUI. So we have taken all the components as we need. Let us place them at their places. So there will be a pulse generator, and then scope at output side. This will be the voltage measurement block, one for input voltage, one for output voltage, and then this will be your AC source, and we will place 4 thyristors over here. You can delete the extra one. Now you can change the name according to your diagram. So this will be your T1, T2, and this will be your T3 and T4. So let us rename it as 1, 3 and 4, 2. So this will be your thyristor 1, this will be thyristor 3, this will be your T4, and the last one as a T2. Now rotate it. So let us connect the cathodes of 2 thyristors to each other and anode to each other. Now anode of this will be connected to cathode of the another branch. So in this way we will form a branch. So positive terminal will be given to the first group, refer this diagram, and the negative will be given to the second branch, that is T3 and this T2 branch. in this way we have connected the AC voltage source, that is your input, and connect this voltage measurement block across it. You can place it outside as well, no issue. Then this will be your output branch. Double click on that. Let us take on the resistive load of 100 ohm. Click on apply and change the name as R load. You can try the similar experiment for inductive load, that is RL load. So load will be connected across this circuit and the voltage measurement block will be connected in this way across this resistor. Now as we are going to observe two waveforms, input as well as output, so we need two ports. So if you are using the latest version of MATLAB, then you can simply right click on that scope, and in signals and ports you will find one more option, number of ports. So by clicking on that you can change the number of input ports to this scope. But as I am using the older version, what I need to do, I have to see for me this third option in signal and ports is not available. Only I have input port, output port, but that number of ports option is not available for me. So I will double click on that, and in this parameters setting you can change the number of access to 2. So by changing this I will get 2 inputs for my scope. So now you can see there are 2 inputs. So one will be for my input voltage and another will be for output voltage. So in this way I have connected it. Now I will change the block name. So this will be my load voltage. So this will be my load voltage, or you can say output voltage, and this one is my input voltage, or you can say source voltage. So as we have renamed them, now the pulse generator, so we are going to so this will be renamed by PG1, this will be PG3, now let us consider the amplitude is 10, suppose period will be 0.02. How to calculate this period? Period is nothing but 1 upon f. T is equal to 1 by f, reciprocal of frequency, and in India frequency is 50 Hertz. So period will be 1 upon f, that is 1 upon 50, 0.02. Pulse width, let us take a 5. And how to calculate the phase delay? Suppose my alpha is say 30 degree. So how to calculate the phase delay? 30 divided by 360 into 0.02. So this is a formula to calculate the phase delay. Let us copy this, click on apply, OK. Now the second pulse generator, we have to do same setting. Amplitude is 10, period will be 0.02, pulse width is 5, and now the second thyristor will be triggered after alpha plus pi. That means whatever the alpha you have taken, that is a 30 degree, plus pi, so plus 180, so 180 plus 30 will be 210. So similarly, alpha plus pi divided by 360 into 0.02. Then click on apply. Give the gate pulses to these thyristors. Now as we know, the diagonal pairs conduct at the same time. So we are going to do the same settings. So for this Pg2, again amplitude will be 10, period 0.02, pulse change the frequency of AC source as well. So frequency will be 50 Hz. Now save the project. So in this way we are done with the connection as well as setting. Now save it and click on run. And to observe the waveform, you have to double click on scope and click on auto scale, so it will be scaled automatically. And you can use these tools to zoom your x-axis as well as y-axis. So I will zoom the x-axis. So you can see this is my input sinusoidal wave and this is my load voltage, that is output of full wave rectifier at alpha is equal to 30 degree. So similarly, what you can do, you can just change the alpha. For that, suppose my alpha is equal to 90 degree, so replace this 30 by 90, click on apply. Similar to this Pg2 as well, so this will be 90. And now for the second group, this will be 90 plus 180 because it is alpha plus pi. If you refer the diagram, this one, so first pulse will be triggered at alpha and the next pulse will be triggered at, this is your pi period plus alpha. So whatever will be your alpha plus 180 plus pi will be the phase delay for the second pulse. So let us change it. So it will be, now we have taken the alpha is equal to 90 degree. So 90 plus 180 will be 270. Similarly, for this Pg4, it will be 270. Save your program, click on run. this is the output for alpha is equal to 90 degree. So in this way you can change the firing angles and you can check the output or output voltage waveform on the scope. If you click on legends here, then click on apply, close this, and again you have to run. So whenever you will double click on scope auto scale, so at right hand side here you will find which waveform is of what. So here you can read this is a source voltage waveform and this is a load voltage waveform. You can give a title to this as well. So this is a alpha is equal to 90 degree. So similarly you can change the firing angles as well as you can change the load. So if you take an inductive load, then you will get different waveforms. So this is all about the practical, that is a single phase full converter with resistive load. So you also try this. Till then, thank you.